So good afternoon, everybody, and welcome to Brookings, India. This month's development seminar is on environmental challenges in India. And our expert today is Professor E. Somanathan, Professor of Economics at the Indian Statistical Institute, or as I like to say in Delhi, ISI. And then people's eyes pop up, and then I have to say, no, they are statisticians and economists, not the extreme exciting variety that you're used to reading in the newspaper. So ISI Delhi, he is one of our prominent researchers who has been very prolific writing on environmental issues, India and globally. Som will have 45 minutes to present an overview of environmental challenges in India. And then our discussant today is Dr. Ajay Mathur, Director General of TERI. He's also member of Prime Minister's Council on Climate Change. Dr. Mathur was also India's key negotiator at the Paris Climate Meet last year, 2015. We will have question answers at the end of the session. So we will start with Som and his presentation, and then we'll take the stage and have discussion and Q&A. Som, the floor is yours.
Thank you, Shamika, and I'd like to thank Brookings for inviting me to give this talk. So I have to say that I'm an economist by background, and environmental challenges are a very big and complex affair. So I'm not going to cover everything, obviously. In any case, that would be possible in 45 minutes. But I'll just say a few words about some of the things that, firstly, there have been kind of in the news more lately. That doesn't mean that other environmental issues are not also very important. It's just that one can't talk about everything important. And also, you know, obviously I'm going to select things about and talk about aspects which my background qualifies me to talk about, and not about other aspects. That said, I will sort of kind of be a little speculative and roam over a fairly wide field because I think that it is important to do that kind of thing and go out on a limb once in a while. So I will do a little bit of that too. So is it not on? Okay, now it's on, I guess. Yeah. All right. So I'm also with the South Asian Network for Development and Environmental Economics, which is the acronym is SANDE. So let me just first give you a quick outline of my remarks today. First, I'll say a little bit about some impacts of climate change and air pollution, which may not be that well known. I will also talk a little bit about methods, just using one of my own papers as an illustration, but of course I won't get too technical. Then I'll talk a little bit about the broader issue of why we have got to this stage. Why have we got to this stage where we have such an air pollution crisis, right? And basically, what I will say is, what I want to argue basically is that feedback processes, social feedback processes to take corrective measures are weak or missing, and I'll say a little bit about why that's the case. And then I'll talk a little bit about the directions in which we do need to move. So for improving environmental policy, I think that at the broadest level, what's needed is more transparency and public awareness. So unless we get those, I think it's going to be very difficult to tackle our problems. The second thing that's really important is that if you want to improve environmental policy, you want a better environment, you're going to have to pay for it. It's not going to come for free. And so I think that's kind of really important, and I'll say just a little bit about that. So regulatory capacity is weak, and it's underfunded, basically, because it's weak because it's underfunded. At least that's one of the most important reasons. I think that we also need pollution charges in particular domains where they are feasible and probably the best instrument. Disposal fees and congestion charges are, I think, two examples. And I think it's also very important to have more experimentation, policy experimentation. I think that we have far too little of that in this country. And And the way it relates to prices and charges is that you really need to deliver some results before you can raise prices. Otherwise, it's politically infeasible to raise prices, and then you get stuck. And then I want to say a little bit about the dangers of climate change. I mean, I'm going to start with climate change, but I'm going to talk about impacts that we have already seen first. But then at the end of the talk, I'm going to come back and talk about some broader issues looking ahead, which are necessarily more speculative. And climate change is not the only changes that we're going to be seeing, or that we are seeing already, but that are going to accelerate in the next decade or two. There's accelerating technological change in some areas, which are related actually to environment. These will present new opportunities, dangers and opportunities. And I think that we will miss these opportunities unless we're collectively ambitious. And these are big opportunities. If we take these opportunities, it can make a huge difference to economic development in India, right? And to the environmental problem. Okay, so let me just go straight into the talk. So here's a graph from a study that we did recently of winter mean temperature in northern India. So you can see that back in 1970, the average temperature was about 24 degrees. And by 2012, it had increased to something like 24.8 or 24.9 degrees on average. Okay. Actually, it says annual mean temperature there, but I think it's really the winter months. Okay. So that's, let me just say a little bit about this paper which just came out last month. Global warming and local air pollution have reduced wheat yields in India. So what's the bottom line of the paper? The bottom line is that the wheat yields are in India estimated to be about 5% lower than they would have been if temperatures had not increased during the study period. Now, is that a big effect? Well, actually, if you look at this, is this supposed to be a pointer here, this green thing?
It won't work on the TV.
Oh, yeah, okay. All right. So anyway, if you look at that, if you can see the numbers on the x-axis, that is the yield in tons per hectare. And you can see that back in 1970, it was about 1.3 tons. And that by about 2012, it had climbed to about 3.1 or 3.2 tons per hectare. So there's been big increase in the wheat yield, right? So that seems contradictory. The temperature went up, things got warmer, and the wheat yield went up. And yet I'm telling you that the rise in the temperature made the wheat yield go down. But what I mean is that it would have gone up even more if the temperature hadn't risen, right? Now, how do we figure this out? Doesn't seem at all obvious, right? So here I'll give you the idea. So as I said, yields, of course, went up for other reasons. They went up because of capital investments and technical progress, not because it got hotter. But if we want to then look at whether the temperature did have an effect, what we have to do is we have to detrend the data, right? So we subtract the trends in the variables from the variables themselves. And the detrended variables, I'll show you in this picture. So those first two graphs on the top, the ones on the top, that one on the top left is the temperature graph I showed you. The one on the top right is the wheat yield graph I showed you, right? And if you look at the panels below, the one on the left is the detrended temperature, which is just that blue curve, those blue crisscross line minus the red line, minus the trend. So it's detrended, which means it doesn't go up or down on average. It's centered around 0 on average. So that's the detrended temperature on the left, and it's the detrended wheat yield on the right, okay? So now what you see basically the year-to-year deviations from the trend, right? So there is a trend in both cases, temperature rising, wheat yield is rising. And here what we see is the detrended in the bottom. And then what we do is the final step is basically to calculate the extent to which the yield goes down when the temperature goes up. So I basically superimpose those two detrended curves on each other. The red line is the detrended temperature. The blue curve is the detrended yield, right? And what you see is that the detrended yield tends to be below 0. So this is the 0, right? And you can see that the detrended yield tends to go down, like here, for example, is below 0 when the temperature is up. Here, again, they're in opposite directions, and so on. So it does tend to, that the relationship is not very strong, but it is there, okay? So that's just a pictorial illustration to give you an idea of the kind of statistical technique that's used to basically see what is the effect of annual fluctuations in the temperature on the wheat yield, right? And the illustration here, basically, in order to make it just presentable in a diagram, just used a single time series for all of India. And what we actually did, of course, is use many time series because you want to make the estimates much more precise and reliable. And so you do that for, say, for one time series for each district, and that's together called a panel. That's called a panel data set, and that's typically what econometricians use now. And in this particular paper, we use data for 208 wheat growing districts over a 29-year period from 1981 to 2009. Okay, so that's just one study. But let me just, before I go here, let me just step back and say that one reason I went into this with you is because I wanted to illustrate that it's very difficult to actually know what is the effect of global warming on some outcome of interest. The reason it's very difficult is because there are many other things going on. There's a lot of noise, and to extract a signal from that noise takes a lot of work and a lot of expertise and a lot of data, right? So it's not an easy thing to do. It's not obvious. So if you just look around you, it's not obvious that climate change, global warming, et cetera, are having adverse impacts, right? Over time, it is going to get increasingly obvious, but we are not yet there, I think. Okay. And hold that thought because I'll come back to it. That the fact that just the very fact, for example, that the daily variation in temperature is far bigger than the amount by which the global mean temperature has risen. The global mean temperature has risen by less than a degree since the pre-industrial era, right? And the daily variation in Delhi, for example, is more than 10 degrees, right? So it's not easy to tell. Just that fact makes it hard to extract the information. And then when you want to look at impacts, then you have the impacts also are highly noisy. So, okay, so it's not easy to do. But people have been doing it, right? That was just one study. It was just an example. And I only gave it not because it's anything exceptional, but just because it's my work, so it's easy for me to give you that example. So other studies have found similar results in warming and wheat yields, for example, using different data sets. For example, a panel of countries, they have similar finding about wheat yields. The magnitudes of the estimates are slightly different, but still similar. Rice yield, which is, so wheat is the second most important crop in the country. Rice is the most biggest. And rice yield in production in India have also been shown to be affected both by warming and by air pollution, just like the wheat in our paper. And in here, there's a study about 10 years ago, data used with a panel of states and Aufhammer et al. In this study, air pollution, the mechanism is that air pollution is shown to weaken the monsoon, which reduces the summer monsoon rainfall, which has an impact both on rice planting, which reduces the area planted, and on the yield on the area that actually is planted. Okay, so far, right, we're only in 2016 so far. Crop yield declines of the order of a few percentage points, right? In my paper, it was 5% per degree increase in temperature on the yield. And since the temperature has risen by about a degree, that's about the magnitude of the effect so far, okay? There are some studies on ozone pollution which suggest that the percentage declines actually may be much bigger than that. But studies based on actual farm yields so far, anyway, haven't been done, partly because there isn't that much monitoring of ozone. Okay, other crops have also been shown to be affected by warming. For example, maize and cotton. There's a very famous study that was done for the United States, published in 2009, which showed very dramatic impacts on maize and cotton once temperatures crossed a particular threshold for those crops. Only for the eastern United States, where the crops are grown in unirrigated, rain-fed conditions, not in the western US, where the crops are grown in irrigated conditions. So things are complicated.
So these are climate impacts, warming and pollution impacts, and they're not only agriculture. So for example, I have a paper with some co-authors which shows that if you increase day-to-day fluctuations in temperature have effects on worker productivity. Again, there's no effect below a particular threshold, and above that threshold, for every degree rise in temperature, you can have quite significant declines. 4 to 9% per degree is really quite a lot. And sustained heat also increases absenteeism under some conditions. And so the first few things are based on case studies, right? So they're true for particular industries which we observed at the micro level. We went and got primary data for those. So they're not generalizable to manufacturing as a whole. But then we also looked at the annual survey of industries, and that is a national level data set and a representative data set. And there we find also that effect does carry through to manufacturing as a whole. There are enough of sub-industries of manufacturing which are affected, even though there's a lot of heterogeneity. Some industries are protected from these effects and don't experience them, but some do. And the overall effect means that that manufacturing output in India is at least 3% lower than it would have been, right? Just because of the effect on worker productivity. Okay. Let me turn to air pollution. So that's a satellite image which many of you may have seen. I don't know. It's northeastern India, basically. So that big cloud is over Bengal. And then you're going back over Bihar, UP, back towards Delhi. And those big white patches are winter fog. And the reason I'm showing this slide is because there's a common misconception, perhaps not well-informed people, but there is among the general public, there's a common misconception that air pollution is an urban problem. And it isn't. It's not an urban problem. It's not a rural problem. It's an everything problem, right, in this country anyway. And as you can see, that the thing I wanted to point out is that if you look at this air pollution here, it's really a misconception to think that Delhi air pollution, for example, has to be tackled by tackling pollution in Delhi, right? Because stuff moves around, right? The jet stream, which is winds at high altitudes, move at several hundred kilometers per hour, right? So a couple of 100 kilometers per hour, right? So pollutants that originate in Peshawar can be in Kolkata in no time, basically, very, very quickly. So, and vice versa. So that's one thing that has to be kept in mind. Of course, not all pollution goes high enough up to be affected by high altitude winds, but even at ground level, there are winds, right, and pollution moves. So what you can see here is really visually, what's absolutely clear is there is a big smearing over the entire Indo-Gangetic plain, right, and also in the Brahmaputra Valley. Then you might notice that Meghalaya, which is hilly, is somewhat spared, right? So what's happening is that the pollution, because of the temperature inversion in winter, is sitting there close to the ground, and wherever the altitude is lower, it's kind of spreading out. So the Chota Nagpur Plateau here is relatively clear, it's spared, right? But this winter I just went down to Puri and Konarak and so on for a holiday, but as you can see, I didn't realize before I went, I should have looked at the image. It was quite polluted there too. Okay, so I just wanted to make that one point here, that pollution moves around, it doesn't stay in one place. So it's really a national problem. Okay, here's another picture. This is aerosol optical depth, which is a measure of basically light extinction in a vertical column. But again, you can see here very clearly the red is the high levels, right? And the left-hand panel, that's October, November, December, January averages. And you can see really that the concentration is along those low altitude areas in the Indo-Gangetic plain, right? In Pakistan, along the Indus Basin, and in India and Bangladesh, along the Gangetic Basin. And the pattern in the summer months, pre-monsoon months is kind of similar. It's less polluted though. Okay. So we've already seen that air pollution has impacted yields of wheat and rice, and of course it also affects health. That's what people are most concerned about. Increases the risk of heart attacks and strokes and cancer, just like smoking. The next slide has a graphic image, so if you don't want to look, don't look at it. It is very graphic, okay. So that's a picture of heart surgery patient's lungs. This was tweeted by the Chief Minister of Delhi, I think, last year. The one on the left is a patient from Himachal. The one on the right is a patient from Delhi. And you can see that that's pretty dramatic. Now, of course, these pictures were probably selected by the doctor in order to make that particular point. So I don't think you should think of this as a representative sample. However, actually, I have seen some other pictures of other patients undergoing heart surgery, and I can tell you that this is the one on the right. There is blackening in other patients' lungs also, right, from completely different source. And the point about air pollution, which I think is from a social perspective quite different from smoking, is it's not a choice made by an individual. It's if you choose to smoke and then you get sick, well, you can argue that, well, that's a choice that you make, right? But here it's quite different, and we have clearly reached a crisis stage. So even on a relatively clear day like this in Delhi, I just checked the PM 2.5 in the US Mandir Marg monitor before I left, and it was something like 94. All right, and this is a good day, as you know, and the PM 10 was 294. So these are much higher than levels that the World Health Organization standard for PM 2.5 is about 25. India standard is about 60, which is arbitrary, basically. Okay, I'll come back to that. So why has this been allowed to happen? It's been allowed to happen because reducing air pollution is complicated, right? It has many sources, among them coal-fired power plants, there's vehicle emissions, there's crop residue burning, there's cooking and heating fires, there's rubbish burning. So, and there's other sources, diesel generators, all kinds of things, okay, which are, there's a long list. There's another big one is road and construction dust and field dust. But I think that from a social perspective, I'm a social scientist, I'm an economist, and so I think that the most important reason it's hard to tackle air pollution is that the feedback processes to correct damaging behavior are weak, right? So, if we look at how markets work, supposing a company sells a dangerous product like this Samsung Note 7, right, that you can't take a flight nowadays without waiting for that announcement. People quickly hear about it and then they avoid it, and then the manufacturer acts fast to change the product. Otherwise, it would go out of business, right? So the feedback is very quick, right? And the reason the feedback is very quick is that because it affects me, right? And I can take an action to avoid that effect. And the sum aggregate of those actions taken by consumers then has a big impact on the entity that is in a position to change the situation. But air pollution, right, isn't obvious. It doesn't kill you like lions do. So if you look at, mortality, excess mortality, right, early mortality from air pollution in India, we're talking about millions of people per year, right? Now imagine that those people, instead of invisibly dying of various diseases, which elevated their probability. So, I can die of a heart attack regardless of even if I lived in the cleanest environment in the world, right? But the fact that I'm living in Delhi means that my chances of dying of a heart attack or having a stroke have gone up, right? And they've gone up significantly, right? But it doesn't mean if I have a heart attack or a stroke that was caused by air pollution. There's no way to make that attribution, right? All we can say is that it's more likely, right? And we can have an estimate of how much more likely it is, and that too is a noisy estimate, right? But imagine that there was a pack of lions roaming around, right? And every now and then they eat somebody in Delhi, right? Can you imagine what the reaction would be, right? The policy reaction. This situation would not be allowed to persist for very long, right? And why? The reason is basically because then the causal chain from cause to effect is completely obvious, right? That's number one. But number two, it's not only that it's obvious, it's that it's dramatic. So evolutionarily, we are all hardwired, right, to respond immediately to clear and present danger. The trouble with climate change is it is neither clear nor is it present, right? Air pollution is present, but it's not clear. Okay, so our evolutionarily honed responses to avoid danger simply don't kick in, right? There's nothing we can do about it in our daily lives, pretty much. You can buy an air purifier, you can buy a whole bunch of air purifiers and put them in your house, and that helps slightly, probably, we hope. Hopefully. Yeah, hopefully, right? At least, it's one of those things you can do and make yourself feel better. Right, but there's really not much that you can do. And so what can you do, right? The problem is it's slow, it's invisible. Nobody is selling clean air, right, except the air purifier guys. The only really practical way to reduce air pollution is for governments to take action, right? Individual actions don't happen because they don't help the individual much. If I drive my car a little less or I buy a less polluting car or whatever, mostly it's other people that are going to benefit. Easier to let somebody else do it. And political feedback processes are much more diffuse than market feedback processes, right? You transmit what you want to a company, you simply don't buy products you don't like, you buy products you like. The mechanism works very well. This is why we economists love markets, right? Markets work very, very well, right? Okay? But for some things, markets don't work, right? You can't buy clean air, as I said, right? You can buy a product that the company claims will give you clean air, and yeah, it'll help you for some part of the day when you're, in that atmosphere, but it's very inadequate protection. And of course, a very tiny fraction of people in this country can afford that. Okay. So to transmit what you want to a government, you can only vote in an election, or maybe you can join a demonstration or sign a petition online or something, right? Doesn't do very much either way. Because elections are about lots of issues, not just air pollution. Air pollution is way down on that list. It's always easier to just let somebody else take the trouble to let the politicians know what you want, right? So what can we do? So what we have to do somehow is to think about improving these feedback processes, because if we can't improve these feedback processes, then nothing we do is going to be sustainable, right? Ultimately, we need public action, because this is a problem where it's a public good. It's not a marketed good. You can't develop a market for it, right? So you need policy action. Sometimes the policy action involves creating markets that can do a job, but you need the policy to get there, right? Sometimes. Okay, so what can we do to improve these feedback processes? So one of the things that can be done is transparency, and I think this is really important, because public awareness matters for policymakers. No awareness, no pressure to do anything, right? From a politician's perspective, it's better to focus on the things the public clearly cares about. That's what democracy is all about, right? You better respond to public demand if you want to continue, to be elected. So if the public is not clearly caring about a particular issue, nothing much gets done about it. Now, actually, air pollution per public, it has risen to the top of the policy agenda in the last 2 or 3 years, I would say, and that has had an effect. We can see that the government is changing, right? So not very long ago, we had this basically no improvement in fuel quality standards, and the Supreme Court intervened at the beginning of the century, right? When they brought in the CNG and they improved the fuel quality standards, things got better. After that, there's been very little improvement, right? Successive governments have dragged their feet on imposing fuel quality improvements on the refineries, right? And also similar standards for tailpipe emissions of new cars, new trucks, new cars. And now things changed, right? Just last year, the government got together. They accelerated this whole program of bringing Bharat 6 standards. Earlier it was 2024, now it's going to be 2020, right? So things are happening, and they're happening in response to this awareness, right? But the thing is that awareness itself is affected by policy, right? Most obviously by monitoring and measurement. If the pollution monitors had not shown that Delhi's air quality was the worst in the world, right, then the media would not have reported it and put it in headlines, and the courts wouldn't be making such a fuss about it, right? It's true that people would be suffering, and there would be pressure just because of the perceptible deterioration of air quality when you just breathe and you just look around you. But it would not have had that much impact without the actual data. The data actually helps, right? So that's one thing I think that's really crucial, and that needs to be something that the regulators do, right? That's something they can influence. They have the monitors, right? So they should be putting the data out, right? Monitoring data should be on the web and should be easily downloadable, easily retransmitted. Actually, the last time I went to the Delhi Pollution Control Committee's website, right? That's the regulator for Delhi. I looked at that website, I looked at the data, and somewhere there it says on the website that you are not allowed to download this data, right? It's only there. You're allowed to look at it, but you're not allowed to download it. Now, this is actually shooting themselves in the foot, right, in my view. So let me come to my next point. You get what you pay for. Like most good things, a clean environment doesn't come for free. Regulatory capacity in India is low, okay? And it's low because funding is low, right? I'm not saying that's the only reason it's low, but if you're going to be starved of funds, then no matter you have all the good intentions and however brilliant you are, there's nothing you can do, right? So we need more funding. Need more funding to hire many more scientists in the pollution control boards. We just don't have enough scientific and technical capability, right? Just look at the numbers of people that India has and look at the numbers of people that China has, right? Or the United States have, right? And you can see it's an order of magnitude difference. It's not that they have 10% more, 20% more, right? They have 100 times as many. And they have people who are, paid a lot more. Who basically, they have technically qualified people who are willing to make careers doing this, right? So, funding, you need that funding. And that's why I said that actually that's how the transparency relates. The existing government data, right, is hard to get hold of. For example, there is a paper written by a bunch of economists on the effect of air pollution regulations on infant mortality and other outcomes in India that came out 2 or 3 years ago. And how did they get the data? They hired an army of research assistants who went to various state capitals and then keyed in the data, right, of monthly averages from books, right? Now, what I'm saying is that to the extent that the regulators have the data, it's in their own interest to make this data, make it easily disseminated and available. Because if they do that, then they're going to get a lot of outside support. If they get a lot of outside support, it's much more likely that their budgets are going to go up, right? Because there's going to be pressure to do something. And you can't do something if you have no regulatory capacity. Okay, so for example, most coal power plants already have electrostatic precipitators, right, to remove smoke from the emissions, right? But how well are they working? Yeah, we have no idea, right? It's not obvious. The media are reporting on air pollution every day, but there's really no detail, right? There's no detail. There's no detail about saying how many plants there are, how much each plant is emitting, when it emits it, right? Why? Because none of that data is in the public domain. Pollution control boards have very limited capacity to monitor actual functioning. They don't have enough staff. They don't have enough equipment. So we need funding, right? And if we need funding, somebody's going to have to pay for it, right? The logical source here is that basically you take some share of indirect taxes that you're already collecting and earmark it on the basis of the size of the industry of a particular state, right? Or something like that. Some fairly transparent formula, right, which will not be optimal, but which will be a lot better than what we have now because it will assure a steady source of funding, right? In the long, that's going to mean that there's going to be a lot more capacity to hire technically competent people, to install equipment, to do the monitoring, to put it out, and to make sensible policy, right? And that will be beneficial for the industry in the long run, because it will enable more scientific and efficient regulation that avoids crises and sudden clampdowns. So right now we have possibly the worst possible way of doing regulation, which is you do nothing, then there's a huge crisis, then somebody goes to the Supreme Court, and then the Supreme Court goes ballistic, right? And does something draconian, right? And yeah, so this is the basic pattern. So what we really need is to move away from that pattern and to give. There has to be enough capacity within the regulatory agencies that you can, how much time do I have? Okay. Enough capacity within the regulatory agencies that you can plan a little bit, right? You can look ahead. You can give clear signals to industry that this thing is we're going to tighten up here, right? And this is why we're going to tighten up. We're going to tighten up because the scientific data shows these health effects. Publish all of this, make it completely clear, right? So that it is immune from legal challenge, right? And then industry will say, okay, yeah, all right, then instead of investing in that, we'll invest in this, right? And they can make plans, right? Which will be basically better for everybody, right? Including industry themselves. Okay, so let me just say that some pollution problems are amenable to the use of taxes or fees. For example, solid waste like plastic bags and bottles, right? The knee-jerk reaction I see in the media everywhere to this is ban it, right? And no. It would be much more sensible, basically, to raise some revenue. You have a disposal tax on manufacturers. Where do you want to collect the tax? You want to collect the tax at the point where the product life cycle is the most concentrated. That's either at the stage of manufacturing or at import, depending on whether it's manufactured or imported. You tax people at that stage and then collect the revenue, and then you can distribute it. So that would incentivize manufacturers in the right direction. And then you can basically calculate how much revenue you need actually to do the proper disposal. And you can then transmit that revenue to the municipal corporations. Now, just because you give them money doesn't mean they'll use it properly, right? There will be problems and so on, right? Money will be inefficiently spent, but at least something will be done, right? And basically it will set incentives in the right direction. Right now we don't have that. Instead we have these draconian ideas that we're going to have this ban, and you put in this ban, and then of course eventually the ban fails to be implemented or enforced because it was unimplementable to begin with, right? Okay. Vehicular congestion and pollution, it's also best tackled through a road use tax or congestion charge. Did I do something? Oh. So because, well, it's common sense, right? If you don't have a road use charge, every improvement to infrastructure encourages more driving. I think I'm pressing the screen button by mistake. Okay, right. You could put more buses, but they don't help only a little because only the poor would use them, right? You have to get people out of their cars. And what the road use fee was, it would discourage driving. It will also raise revenue, and this is really important, right? It's not as if our cities have tons of revenue to spend on anything they like. Better public transport, better pavements, bicycle lanes, and you have to have much higher quality public transport. Otherwise, nobody's going to get out of their cars, right? So it's quality, right? And that's why I think that there's a particular, right now the Delhi government is talking about reducing the fees for buses. This is exactly the wrong idea. It's a wrong idea because what you need is to improve the quality and reliability. Then people will get in, right? You could subsidize the buses, but the revenue has to come from somewhere. And so it had better come from a congestion charge. That's the only way to go. Here's just some graph to show you that taxes actually work. In the left-hand panel, we have the price of gasoline over time in selected economies. On the right-hand side, we have the actual gasoline consumption per capita. All I want to show you here is the ordering. Look at the ordering. On the left and the right, it's reversed exactly, okay? Okay, here's another graph which shows you basically the same thing. We have liquid fuel emissions intensity, kilogram CO2 equivalent per $100 of GDP on the horizontal axis, and we have the price of diesel on the vertical axis. And as you can see, there's a clear relationship, yeah? You reduce the price and you get very large emissions intensities. Changing lifestyles. People talk a lot about this, and my reaction as an economist is to say, you want to change lifestyles, change prices. Oops. Tax activities that could be discouraged, subsidize activities to be encouraged, and that's likely to work better than telling people not to switch on their air conditioners. Okay, I think that environmental consciousness and moral suasion have an important role to play. I don't want to discount those. I think they're really important. But I think people have the wrong idea about what role they have to play. The role they have to play is not that you reduce emissions because you live a more virtuous life. The role they have to play is that you raise issues in the public discourse until they become important in the public discourse, and that is the only thing that will prompt state action, right? Okay. Trouble with raising prices is it loses elections, right, in every country in the world, right? But not always, right? Gradualism helps. Remember the diesel price increase? Since 1991, every finance minister would say that we're going to reduce the fuel subsidy, we're going to reduce the fertilizer subsidy, and so on and so forth, right? And it never worked. It never worked until finally they came up with the plan that we're going to do it at 50 paise per litre per month, right? So when they announced that, there was a noise. But then they just stuck to it, and then basically the noise fades away. And the reason is essentially because it's gradual, people adjust to it, right? It reduces disruption, people buy new equipment. There's a second reason that price increases are resisted by the public, and this is a very good reason, which is the public has no confidence that the higher prices will lead to better service, right? So you look at water supply, for example. Very poor reliability, very poor quality, right? But there's low water prices, which means there's no money for investments to improve the quality and reliability. So how do you get around this? First thing I want to say is that, by the way, this is not because we're a poor country. Yes, it's partly because we're a poor country, but there are other poor countries that have done it. So on the vertical axis, I have the percent of customers who get a 24-hour supply. And if you look at the top there, all those dots at the top, there's 100%, right? That 100% is, of course, true in cities in Japan, which is on the top right, right? But it's also true on the top left, right? Those are cities like Phnom Penh in Cambodia, much poorer country, right? And cities in Central Asia, right? Other cities in Southeast Asia, Vietnam, for example. So it can be done even if incomes are low, right? So what you need to do is you need to basically get over this vicious cycle, right? Low quality, low prices. Because prices are low, you can't raise quality. Because quality is low, the public says, I'm not going to pay more. This is for just lousy service. So you need to experiment, right? You need to do it in a gradual way. The same principle applies to other kinds of pricing reforms, right? But I have to say that experimentation without monitoring and documentation is useless, because you can't then learn from either the failures or the successes. So we need again, comes back to that issue of transparency. If you can document what you're doing, you have a much better chance of succeeding. And that brings me to the fact that governments are bad at experimenting because bureaucratic incentives are very hostile to failures, right? If you're a bureaucrat, you know that you're going to get punished if something goes wrong when you were in charge, right? On the other hand, you're going to get promoted basically and go up the ladder pretty much regardless of what you do, right? So the upward incentives are not as strong as the downward incentives. And so we really somehow need to break out of this trap, right? We need some kind of active policy to encourage small-scale experiments with monitoring and documentation that can be scaled up if they work, right? I think this is really important. It's a major advantage of decentralized governance. It's one of the reasons why China has actually done extremely well economically, is because they had this decentralized local government system that allowed a lot of experimentation. I think I'm going to kind of running out of time. Yeah, so can you give me just 2 minutes? I'm almost done. Yeah. I mentioned this already, actually. So let me just say that a couple of things. You know, there are a few areas where quick progress is possible, and this is really important because if you can make progress, then you can build public support to do more things. So one of the things is crop residue burning. There's a machine to sow wheat that does not require removing rice residue, right? It's been around for a few years. It's no more costly than conventional seeders on net. There's a paper by my former PhD student, Ridhima Gupta, that did a study in Punjab that showed that if there was a concerted push to subsidize it and push it out in the northwestern states, it could make a big difference even before next winter. Right? Punjab Agricultural University has the expertise. They're building the machine. They're improving it every year. It's possible. Okay? So what it really needs is somebody in the government of India to talk to the Punjab government and to get the money flowing. Right? And it'll happen. Here's another thing that, so here, this is just made up data, okay? I just made it up, but it's an example because we don't have good data. So what I have here is supposing you order the vehicles from least polluting to most polluting, right? That's percentage on the horizontal axis, and that's pollution level on the vertical axis. Most pollution distributions look like this. They look like this because the most polluting vehicles, there's a small number of vehicles that actually pollute at much greater levels than other vehicles, right? you can take advantage of that fact. So in this made-up example, the worst 10% of vehicles account for close to 50% of the pollution. But that is not unrealistic, okay? That has been found in data from many countries. We don't have the data in this country. I'm always complaining that we don't have enough data. Okay, so if we take these vehicles off the road, it would have a noticeable effect on air quality. So this is something you could do relatively quickly. You could do it relatively cheaply. You could compensate people because you're changing the policy abruptly, right? So that's another quick thing we could do. We're actually planning to actually get some data to do this. And then, of course, you'll have to, going forward, you'll have to sort of make sure that this policy is consistent, right? Okay, last thing I wanted to say. Think about global warming, is that I mentioned the effects at the beginning, right? And those are all of order of magnitude, a few percentage points less of this or that. That's not the real reason why people talk about climate change and they're worried about it. You're really worried because you're afraid that something will happen which will lead to something else, which will lead to something else, right? And will tip us into a completely different state. And the scientists talk about that as something, scientific states, different ecological systems, different zones. As a social scientist, I'm much more worried about tipping our social and political and economic system into a completely different state, right? A rise in average temperature also implies a rise in the frequency of very hot days. Extremes also increase. And we are going to get extremes we have never experienced, right? Last year, we broke the record for the temperature in India, right? Okay, it didn't have a big impact. But it could, right? We did have a heat wave that killed many people. We don't exactly know how many. What happens if we get a much bigger heat wave, right? That's going to be like the lions walking around eating people, right? You can't do business as usual again if that happens. We don't know whether that will happen. But there are many other things that could happen, right? Too many dimensions. That's the trouble with climate change. There are too many dimensions. It affects things on too many dimensions. In that case, we would have to have emergency options, such as geoengineering, right? That could, of course, trigger international reactions. So my point is that, look, these processes could tip us into something we're completely unprepared for, and it could happen very quickly. That's the danger, right? If we just keep on drifting. So we really need to plan for these eventualities, and I think that climate change really, it's time to stop talking about it as an environmental problem, because it's really much bigger than that. And I think we need to treat it at that dimension. Let me just say that also there's good things coming, and we should take advantage of these good things. There's gene editing technologies that can help a great deal. There's new technologies on air pollution sensors. Battery costs are falling rapidly, right? That's going to upend the electricity system in the next decade. We should be accelerating these developments. We should be planning for them, and we should be in a position to take advantage of them. But I'm afraid that the way things are going, we haven't, right? We're not ready to acknowledge that the rate of change in particular dimensions in technology is really going to be very, very quick. Right? It's not only in environmental areas. So I think we need collective ambition. We need public policy experiments. Otherwise, we may not reap the benefit of these developments, and we really don't have that much time. So we should get going.
Thank you. Thank you so much.